Okay, so let's just start with the let's start with the exponential equation. So we are going to share with you different tools to solve the exponential equation. Let me give me 1 second. Let me move this out of the way really quick. Okay, so the first thing is that the first tool that we are using right here is that if we give an exponential equation that have the same base, they both the left side and the right side is only have one single term on the left, one single term on the right. There no express. It's only one term, and then they both have the same base. Then if they have the same base, then we can conclude that the exponent will be the same, and then that would be the way to solve. So this tool only apply for the exponential equation that have the same base. Okay, so same base. So I want to make sure again, same space, same exponent. Okay, so let's start with exercise number 1. As you can see right here that it doesn't look like that, but we can make it look like this. On the right hand side, 125, we can write them as 5 to the power 3. Okay. So copy the left side, 5 to the power of 3x minus 1. On the right hand side, 125 is 5 to the power 3. Okay, so now we do have same base, right? So now we can conclude that they will have same exponent. So the exponent on the left hand side 3x minus 1, the exponent on the right hand side is 3. So now we can solve this exponential equation so easy, right? Because now it become a linear equation. We add 1 to both sides, so be 3x equal 4, and then divide both sides by 3. And again, of course, you can check the answer by substitute x for 4 over 3, and then you will see that the left side and the right side give us the same result. Okay, so the first thing is that just go ahead and write them in base 2. Okay, so 1 4 is 1 over 2 to the power 2, and then on the right hand side, 8 is 2 to the power 3 is 8, and of course we have extra exponent, so 8 to the x with 2 to the power 3, and all that to the power x. Okay, next. We can go back and we can go ahead and write them in term. Now here on the left hand side we have a fraction, but this is a reciprocal, right? So 1 over. So we go ahead and write them as flip it over. So be 2 to the power of negative 2. So that will be our left hand side. And our right hand side, since we have the 2 exponent, we will multiply. So 2 to the power of 3x. Now we can see that both sides, we only have one term on each side. They both have the same base. So it means that we must have the same exponents, which is negative 2 equal 3x. Now I'm going to go ahead and divide both sides by 3. So then we can conclude that x is negative 2 over 3. And of course, you can go back and check your answer by substitute x for this fraction, -2/3, and then make sure that the left side and the right side have to end up with the same answer. May I see? Okay, there. Okay, so let's look at exercise 3. So again, what is the goal here? To solve all this. So the tool that we have right now is to solve exponential equation. We must have to use this type of tool, we must have only one term on the left, one term on the right, and both terms have the same base, so that we can set the exponent to be equal. Okay, here we don't see they have the same base yet, but we are going to write them so that they will have the same base. Okay. On the left hand side, the base is a. So I'm going to write them in terms of base 2. So 1 is 2 to the power 3 is a, and then copy the rest of the exponent. On the right hand side, the base is 4, but 4 we can write them as the base 2. So 2 to power 2 is 4, and then copy the rest of the exponent. Now we can see that they both have the same base. Of course, we can rewrite and make them look nicer before. So go ahead and multiply 3 with x plus 3. So that the exponent now will be 3x plus 9 on the left side. On the right side will be 10x minus 4 for the exponent. 10 minus 4x for the exponent. Okay, now both sides have the same base. So therefore they will have the same exponent. So 3x plus 9 equal 10 minus 4x. So now I'm going to go ahead and solve this very simple linear equation. When you go ahead and add 4x both sides, so that gives us 7x. And then subtract 9 from both sides, so give us 1. And then from there, we go ahead and divide both sides by 7. And again, you only can go back and check to see if you find the correct answer by plugging the value of x into the equation. Make sure that the answer from the left side equal the answer from the right side. Now let's look at exercise 4. This method, it doesn't work all the time. The reason it doesn't work all the time because sometimes we cannot have the same base on both sides. So if you look at exercise number 4, you can see that we cannot use the method that we just introduced, make sure both sides have the same base. We cannot. So when we get to this, we have to take log from both sides. Okay. Now, when we take log from both sides, it doesn't matter what base we want to do. Okay, I am going to do both cases so that you see. The first one, I'm going to go ahead and do base 10. So I'm going to do logs of 2x equal logs of 7. And I'm going to make a quick note right here for you. Any log maybe you. So what I mean is that let's try with the natural log. Natural log of 2 to the power x equal natural log of 7. And then, I mean, you will come to take any log base, but then on your calculator, it's only have two key that only program on there for us, which is base 10 and base e. So that's why I'm just go ahead and stick with base 10 and base e. Okay, let's go back here. So after we take log both sides, we are going to use the power property. So I'm going to move the exponent to the front. So we x times log base 10 of 2 equal log base 10 of 7. Now I'm going to go here. If we do the natural log, so it'll be x times natural log of 2 equal natural log of 7. All right. And then lastly, again, we isolate x, so we go ahead and divide both sides by log, in this case, be log base 10 of 2. So we do log base 10 of 7 divided by log base 10 of 2. Now, can you put in the calculator for us? And then while you're doing this, I'm going to go ahead and take care of the natural log. I mean, the answer have to be the same. So natural log of 7 divided by natural log of 2. Okay, now can you put in your calculator, please? Can you check the answer? I'm going to go ahead and route to 4 decimal places, which is 4 number after the decimal point. So 2.8074. Both for the common log and for the natural log. Can you check to see if you have the same answer with us, please? Thank you so much, Christina. Okay, so let's move on to exercise number 5. So sorry, I'm just skip my number. So from 4, I'm jump on to 6. I'm so sorry about it. Okay, so here, the first thing again, we'll take block. So again, it doesn't matter. You can pick between your common log and your natural log. Of course, you can take whatever log base, but those are the two base that our calculator have it. So I am going to do natural log. Okay, so I'm going to do natural log of 3 to the power of negative 0.02x equal natural log of 0.07. Then now I'm going ahead and using the power property to move the exponent, which is the negative 0.02x in front of our natural log 3. And next, we want to isolate x. Okay, so we want to keep x, and then the rest, when you go ahead and move on the left-hand side, we move it to the right-hand side by dividing. So natural log of 0.07 divided by negative 0.02 times natural log of 3. Now, dear, can you try to practice along with us? So put in your calculator, please, to see if you end up with the same answer with us. So again, we route our answer to 4 decimal places. Thank you so much. Okay, so do we have 121.0281? Thank you so much, Christina. Okay, let's look at the next exercise number 7. So as you can see right here, compare with exercise on the previous 2 exercise here, we just cannot go and take log right away. First of all, we cannot use the method that because both sides they don't have the same base, so we cannot just go straight and use that method to get the exponent. Both sides will be the same, so no. Then we have to take log, but we cannot just take log right away because to take log, we need to isolate the term the term that have the base with and the exponent by itself first. So on the left hand side, we can go ahead and subtract 4 from both sides. So after we subtract 4, then we left with 3 times e to the power of 2x equals 7. But of course, we still cannot take log right away because we need to isolate e to the power of 2x by itself. Okay, so I'm going to go ahead and divide both sides by 3. So now we're left with e to the power of 2x. So the base is e, the exponent 2x by itself. And then on the right hand side, we have a fraction 7/3. Now we can take log. Okay. Now since the base is the base e, it's good that we take log with the same base, which is the natural log. So because if you remember, if we take log base b of b give us 1. Log base b of b to the x give us x. Or I can say log base b of b to the m give us m. These two exactly the same. I'm just kind of writing my exponent at x and m. So here we want to, because this is the base e, so I'm going to have and take the natural log. Natural log of e to the power of 2x equal natural log of 7/3. So natural log of e to the power of 2x using the property that we have here, same log of base b of b or log base b of b to the x gives us x, or log base b of b to the m gives us m. So this gives us just 2x equal natural log of 7/3. And then lastly, we just go ahead and divide both sides by 2. So our x is natural log of 7/3 divided by 2. So can you put in the calculator for us, please? Can you check your answer with us to see if you end up with this answer? So again, it's not an exact. So this is about 0.4236. Thank you so much, Christina. Okay, so just again, keep in mind that so far we solve exponential equation. We have 2 tools to use. The first tool is if the left side and the right side of our given exponential equation have only one single term on each side, have the same base, easy. We just set the exponent equal and we get that done fast. But if the base they do not match, then we have to take log. And then we have to use the power property. But before we take log, we have to make sure that the left side, we have to isolate the exponential term by itself before we can take log. Okay, let's move on to exercise A. So here, of course, the base on each side, they are not the same. So we have base 2 on the left, base 3 on the right. We cannot use the first method, set the exponent equal. Now we have to take log. Okay. We can use whatever log base, but of course in our calculator, the base 10 and the base e will be the key that we have up there. So I'm just, I guess I'll just use base 10. Okay, so I'm gonna do log base 10. So again, base 10, we don't have to write this, but we have to know that the base is base 10. 3x minus 2. Okay, so what it means, this is log base 10 of 2 to the power 3x minus 2. Log base 10 of 3 to the power 2x plus 1. Okay. Next, we are going to use the powers property. So we are going to move the power or the exponent to the front of the log. So it'll be 3x minus 2 times log of base 2 equal 2x plus 1 times log base 10 of 3. I'm so sorry. Sometimes I talk and then I didn't say the base. I'm so sorry. Okay, so now the next step, we can go ahead and distribute. Okay, so this give a 3x times log base 10 of 2 minus 2 times log base 10 of 2. So that is the left side. Now the right side, we do exactly the same thing. We distribute the log base 10 of 3 to remove our parentheses. So we have 2x times log base 10 of 3 plus log base 10 of 3. Because when we multiply by 1, it's just the identity. Which is now when we multiply by 1, the product stays the same. Okay, so now we clear the parentheses by distributing. The next step is that we have to move all the terms that have x on one side. Yeah. So what we mean is that the 2x times log base 3, we have to move it to the left hand side by subtracting. Okay, so I'm gonna write it down right now for you. So we have 3x times log base 10 of 2 minus 2x times log base 10 of 3. Okay, and the term that doesn't have x in there, which is on the left hand side is 2 times log base 10 of 2. We're gonna go ahead and move it to the right hand side. So it become a plus. Let's write it down. So we have log base 10 of 3 plus 2 times log base 10 of 2. I hope that it's not very confusing for you. I'm trying to use the color code to be easy for you to see. Okay, so let's go back to the left hand side. So on the left hand side, we can go ahead and factor the common factor, which is the variable x, so the factor is out. The rest, so the leftover from each term, so we have 3 times log base 10 of 2 minus 2 times log base 10 of 3. So that will be left side, and on the right side, we just go ahead and copy both, because here we just write them both, but when we put in our calculators, then you will have a decimal, an estimate So this is log base 10 of 3 plus 2 times log base 10 of 2. Okay, lastly, we get to the end. Yay! Okay, so lastly, we isolate the variable x. So x equal log base 10 of 3 plus 2 times log base 10 of 2 divide by 3 log base 10 of 2 minus 2 log base 10 of 3. Now, can you help us to put in the calculator, please? And can you check your answer with us, please? So this is an estimate. So x equals negative 21.0973.